Name's Jason Pinchback. I work at the Texas General Land Office. I'm excited to welcome you all to a lunch and learn we'll be doing today. Before we begin, just wanted to remind folks who are attending to please keep your microphone on mute. Feel free to have your video on and off at your discretion. Today's meeting is being recorded and it'll be posted for use at a later time. So you can also share this with your colleagues who aren't able to make it. We'll have a question and answer session at the end of the presentation today, so feel free to include your comments or questions, etc., in the chat, and we'll address those towards the end. Let's go ahead and review the agenda briefly. We'll introduce our project team helping to facilitate our meeting today. Then we have a presentation, Pressures on Water Quality in Texas, Now and in the Future, featuring Dr. Mike Wetz. We'll have a Q&A and we'll wrap up and we'll get you out before noon. I'd like to introduce our Lunch and Learn team, starting with Ms. Sarah Wingfield. She is the digital media specialist for the Meadow Center on the Water and the Environment. In her role at the Meadow Center, she ensures water research is made accessible to decision makers and the public. Her role with Clean Coast Texas is to provide technical support for the Lunch and Learn series, so be sure to reach out to her with any technical issues you might have during the day. Sarah, thanks for your help in making this happen.
You're very welcome, Jason. Hi, everyone.
We are also joined by Miss Ashley Bennis. Ashley is the coordinator of the Clean Coast Texas program. Her background centers around environmental planning and risk management, working closely with Texas coastal communities to improve planning processes and adopt updated policies to enhance coastal resilience. Ashley is a certified floodplain manager and has obtained a certification from the Waterfront Edge Design Guidelines, also known as WEDGE. This is a designation for coastal communities that meet the requirements of mitigation coastal risk, guaranteeing public access to the water, and working with native natural resources to improve quality of life. As a leader on the Clean Coast Texas team, Ashley will focus on coordinating the public and private partners to research and develop innovative policies, techniques, and funding mechanisms to successfully implement low-impact development and nature-based solutions in the coast. Ashley, thanks for joining our team.
Thanks, Jason. I appreciate that introduction. Hi, everyone. It's good to be here. I'll be taking over as the coordinator for the next couple of years, and please reach out to me if you're a community interested in learning more. So, thank you.
Thanks, Ashley. And we are. Welcome to another installment of the Texas General Land Office Clean Coast Texas Lunch and Learn series, where we connect with coastal water resources and learn about ways to understand and enhance the sustainable management of stormwater runoff. My name is Jason Pinchback, the Water Resources Manager at Texas General Land Office, working under the leadership of Commissioner Don Buckingham, ND. This event is sponsored by the Texas Coastal Management Program, and it is intended to be an easy-to-access forum where we invite subject matter experts to unpack their initiatives into bite-sized morsels, to share ideas that might be useful for neighboring coastal communities on how to improve local water resources. Clean Coast Texas is here to serve communities by providing local governments, decision makers, and the public with information, resources, and tools to better manage their stormwater. The tools and guidance provided through Clean Coast Texas can help communities implement measures to reduce the impact of land use change on coastal waters and protect natural resources that support a thriving Gulf Coast economy. Some examples of our resources include community planning and ordinance development, water quality analysis and green infrastructure workshops that help to bring meaning and value to how to implement low-impact building and development practices, grant development and project management, stormwater retrofits and green infrastructure demonstration projects, and other measures, including public engagement materials. To assist the GLO with this initiative and knowing this type of challenge takes a well-seasoned and knowledgeable group of practitioners, the GLO formed a collaborative, which is led by the Harte Research Institute, or HRI, at Texas A&M-Corpus Christi, includes Texas Sea Grant at Texas A&M, Texas Community Watershed Partners at AgriLife Extension Service. Before we begin, I would like to thank Sarah Wingfield and Ashley Bennis for your assistance in co-hosting and providing technical support. Today's featured presentation is provided by Dr. Mike Wetz. Mike Wetz is the chair for Coastal Ecosystem Processes at Harte Research Institute at Texas A&M-Corpus Christi. He is broadly trained marine scientist who studies plankton ecology, ecology of harmful algae, and coastal water quality. Much of his research over the last decade is focused on solving regional environmental problems. In recognition of his efforts, Wetz has received several awards from local conservation entities, include Conservationist of the Year, awarded by the Coastal Conservation Association, Higher Education Award, twice awarded by Coastal Bend Bay and Estuary Program. Dr. Wetz leads a volunteer water quality sampling program in Baffin Bay, and results from that study are now guiding watershed restoration and protection efforts through the Bringing Baffin Back initiative. So let's buckle up, put on your thinking caps, and get ready to learn. Without any further ado, let's welcome Dr. Mike Wetz.
Thank you, Jason, for that very nice introduction. Just want to make sure my screen is working. Are we all good?
We can hear you, and you're in presentation mode. Looking good, Mike.
Perfect. Thank you. Thanks for being here. I really appreciate the opportunities about coastal water quality here in Texas. I want to first just acknowledge my co-author, Dr. Nicole Powers, who's been working with me on assessments of water quality conditions on the Texas coast. So today's talk is going to focus on some of the pressures and challenges that we have in terms of water quality on the Texas coast. So what I'd like to do is just start off to give you a very high-level overview of some of those pressures, and then we'll dive a little bit into the data to see what kind of water quality challenges we may have on the Texas coast. And throughout this talk, I'm going to also refer to some future lunch and learns, because we have some really exciting future speakers who are going to talk about opportunities to address some of the water quality challenges we have. So let me go ahead and just dive into it and talk about some of the pressures. So the first and most obvious one is the quote unquote Texas miracle, which is that people are moving here. The Texas population has increased dramatically over the past 3 decades. So just as an example, from 2010 to 2019, we've had about a 15% population increase in our coastal watersheds. And so what this means is we're seeing very heavy rates of land use conversion. So taking what was natural rangeland or pasture and converting that into more urbanized areas. So this map on the right is an example of where the highest rates of land use change are happening. So for example, you see that the Austin-San Antonio corridor there, up around Houston, down in the valley, up around Dallas. So these are all areas where people are moving to. And so what this means is as you get more people in our coastal watersheds, that's going to put pressures on our freshwater systems. So people need water for consumption or irrigation or whatever. So we're seeing this increasing demand being put on our freshwater systems. And what that means is that over the long run, there's going to be less fresh water moving down our rivers, down to the coast. And what this eventually will do is affect the salinity of our bays and estuaries, which then affects habitat, affects how productive the estuaries are. It affects how well flushed they are and their ability to kind of cleanse themselves when they get hit with pollutants. So a lot of changes happening in our coastal watersheds that's affecting how much water is making it down to the coast. And I just want to give a brief shout out. The first future lunch and learn. The General Land Office just funded a project that was recently completed by Dr. Paul Montagna at the Harte Research Institute that did a really amazing synthesis of all the known freshwater inflow science on the Texas coast. So we're aiming to have Paul talk about the results from his study at a future lunch and learn this year. So please keep an eye out for that. So aside from impacts on water quantity, this population increase has potential to affect water quality as well. So for example, when you have more streets and more sidewalks, In the absence of what I would consider best management practices, you can end up with more stormwater runoff. In addition to that, by default, more people, that means you're going to have more sewage. So more influences of wastewater effluent, but also potentially septic tanks, especially in the more rural areas. So this map on the bottom right just shows an example of how the number of septic tanks has changed over time. So on the left, it shows as of 1990, about 1.3 million septic tanks in Texas. And by 2016, that was up to about 2.2 million. And of course, a lot of those are happening in that in the coastal watersheds. So there have been a lot of studies done across the US and elsewhere looking at the impacts of this urbanization and population increases and what it means for water quality. So in the absence of really solid best management practices and sewage treatment, things like that, you often see increasing nutrient loads like nitrogen and phosphorus, more bacteria, more sediments, trash, oils. All of those tend to be associated with growing populations and increasing urbanization. So while this Texas miracle is great for the economy, obviously means the state is doing well from an economic standpoint, we have to be careful about how we balance that growth with the needs of the environment as well. So I'll talk more about some of the changes that are happening in terms of water quality here in a few minutes. So aside from the direct people factor and pressures on water quality, we have considerations due to changing climate. So for example, it's getting warmer. What that means is that from a water quality standpoint, as your waters start to warm, one of the more direct impacts that has on water quality is that warmer water tends to hold less oxygen, which things like fish and other critters need oxygen to survive. That's just one of the many potential impacts of warming waters. But also, and this is from the state climatologist from a report they published a few years ago, parts of the Texas coast, especially in East Texas, seem to be getting wetter over time. But then parts of West Texas, and especially out into West Texas, it's getting drier. So why that matters for our bays and estuaries is that some of our watersheds, like for Matagorda Bay, that watershed runs all the way out into West Texas. So that drying factor out there potentially impacts how much water is going to make it down to Matagorda Bay at some point. And then in some places, there are indications that we're getting more intense, sort of short-lived but intense rain events, especially over there in East Texas again. So all of these factors kind of come into play in terms of affecting not only the water quality, but the quantity of water making it down to our bays and estuaries. All right, so that's kind of the background, the broad overview of what's changing. So the focus of this talk is going to be really to delve into the actual water quality data that we have and looking at what is changing in terms of water quality, focused on salinity, bacteria, and nutrients. So I'm going to talk a little bit about where the problems are, offer some insight into what the potential drivers are, and then also talk a little bit about what the future might hold for this. So one of the really nice things for a scientist like me who's interested in water quality here in Texas is that we have some really good data sets by which we can assess changes that are happening on the Texas coast in terms of water quality. So for example, the TCEQ Surface Water Quality Monitoring Program, it measures water quality in almost all of our bays and estuaries on a roughly quarterly basis. And some of those data sets, especially for salinity and nutrients in certain bays, it goes back 20 years, sometimes upwards of 40 years. So we can really start to assess what changes are happening. And then on top of that, we have the Texas Beach Watch program, which measures bacterial conditions on a lot of our recreational beaches up and down the Texas coast. And that data set's about approaching 20 years now. So some really good data sets to work with. So I'm going to start off talking about salinity. you're going to see maps like this throughout my talk. And there are a couple of things shown on these maps. One is these background colors. Those correspond to a general average condition over, say, like the last 10 years. So in this example, this shows salinity from Sabine Lake down to Baffin Bay. Red colors indicate higher salinity levels. Bluish and greenish colors indicate lower salinity levels. So the other thing you'll see are these dots. These are all sampling stations where we had at least 10 years of data by which we can feel good about assessing changes or trends over time. So in this case, for salinity, red dots would indicate increasing trends, black dots indicate no change, and gray dots indicate where we might not have enough data. So let's dive into this. So the first thing you see in the background is that on the north coast, we have these lighter, the bluish colors, and that indicates lower salinity waters in Sabine Lake, where you get a lot of fresh water coming down, parts of Galveston Bay. And then as you move south, the salinity gets higher. So this corresponds with a very well documented precipitation gradient on the Texas coast. So the other thing to note, though, that when we talk about changes, there are some places where we're starting to see indications that the salinity is creeping up over time. So some of the stations up in Galveston Bay, we see quite a few here up in western Matagorda Bay and Lavaca Bay in particular. We have a station in Copano Bay and then a station up in Nueces Bay. These are all, again, places where the salinity has been increasing over time. And the rate of increase that we measured is about 0.16 units per year. This is also very consistent with a recent analysis that some scientists at the U.S. Geological Survey did as well. So one point I forgot to mention that I just wanted to really go back to, which is that this salinity gradient, why it matters is because it kind of dictates what types of habitats can thrive there and be supported. So for example, these lower salinity waters up on the north coast, you tend to get marshes and wetlands. And then as you move south into the saltier waters, you get a lot of seagrass beds and things like that down in this area. So what these changes mean over time is that you're potentially going to change the character of the bays, especially as salinity starts to creep up. That's going to affect the types of habitats that bay can support. I want to give one example of what a long-term salinity increase may mean for a bay. Probably one of the best examples we have is the Nueces estuary here in Corpus. Back in the early 1900s, before we had any damming on the Nueces River, the Nueces estuary was brackish, which means it had salinities on average in the teens and maybe low 20s. And it supported this really incredible oyster fishery. There's all these great historical pictures of just giant mounds of oysters that had been harvested from Nueces estuary. And then between the 1950s and 1980s, we had several large dams or reservoirs constructed on the Nueces River. So instead of allowing that river water to flow downstream naturally, now a lot of that fresh water was impounded behind these dams. And so today what you see in the Nueces estuary is there's no real salinity gradient. And instead of having those brackish conditions, now hypersalinity is common. So what hypersalinity is, it's when the salt content of the water is higher than that of the ocean. So it gets really salty in Nueces Bay. And you basically can't grow oysters in the bay anymore. They just don't do well in those very salty conditions. So this is one example where increasing salinities over time can really impact the sort of character of a bay and estuary. So now looking forward, what does the future hold? Well, so this upper figure is a projection of population growth in Texas. So in 2024, we were at about 31 million people. And according to the state water plan here, by 2070, we're going to be at about 50 million-ish, if not more. So you couple that with the increasing temperatures from the changing climate around us, which increases evaporation and water loss. And what that means is that we're likely going to continue to see decreases in the amount of fresh water that is available for our bays and estuaries, which is probably going to lead to increasing salinities in our bays and estuaries and changes in the nature of those bays and estuaries. Okay, so now switching gears, looking at fecal bacteria pollution. Over the past few decades here on the Texas coast, we've had a few localized hotspots for fecal bacteria contamination. And this has typically been linked to things like wildlife, which is natural, so it's a little bit difficult to deal with that. But also in some cases, stormwater runoff or failing sewage infrastructure. And why this matters is because for swimmers and beachgoers, when you have high levels of bacteria in the water, if you ingest that, it can give you some gastrointestinal issues and sometimes very severe. And of course, it creates perception problems as well, which none of us want in our coastal communities. It's not great for the coastal economy. So let's take a look at what we've got here. So again, we've got this map. The reds indicate higher levels on average of this indicator enterococci. So up here around Galveston, some areas around Corpus Christi Bay have relatively high levels on average. And then on the central coast, San Antonio, Matagorda Bays. What's particularly pertinent here are the dots. You see a lot of red dots. And essentially what that means is that the data is showing an increasing trend over time in all of these areas where you have red dots. And that is a pretty significant fraction of the sampling stations. So up here around Galveston, Surfside area, parts of Corpus Christi Bay, out at the beaches on Corpus Christi. So a lot of challenges here in terms of these bacterial pollution issues. I also want to highlight, though, some places are doing well. You look down at South Padre Island, relatively low bacteria levels on average and no obvious trends over time. So shout out to South Padre Island. They seem to be doing very well there. So 2019 was a very interesting year and an informative year, I think, for some of these issues. There was a widespread fecal bacteria issue for much of the mid-coast of Texas during the summer. It was quite prolonged. So starting in roughly mid-June, we started seeing, by we as a Beach Watch, started seeing very high bacteria levels throughout much of the central Texas coast. And those levels tended to stay elevated all the way through September. So Beach Watch folks reached out to some researchers to try and figure out what is going on here, what's up, what's behind this issue. And so Nicole Powers and Jason Pinchback and others, co-authors on this paper that came out, they looked at some of the changes in bacteria levels on the Texas coast, and including during this event. And so what they found was that there was a correlation between the bacteria levels and a couple of different factors. One was the number of humans in the watershed, so population correlated with high numbers of bacteria, but also sea level. So coincidentally, 2019 turned out to be a fairly high water year on the Texas coast. And so what these authors found was that as water levels increased, there was a correlation with increasing bacteria numbers as well. So this map on the, or this figure on the right shows the water level in Galveston, just one example. And you can see there's been a steady march upward, but then a fairly sharp increase in 2019. So on the Texas coast, we do have a relatively high rate of sea level increase. That is due to a number of factors, subsidence, but also the changing climate around us, warming waters. And so one of the suggestions in that paper and by the researchers who are doing the work, they took a look at where this is happening elsewhere. And coincidentally, around the same time, started seeing that South Florida was dealing with these issues fairly extensively. And what the folks down in South Florida had noted is that As the water levels were rising, they were coming into contact with the drain fields from septic tanks. And that was an apparent major contributor to the bacterial pollution down there. So there's this general theory now that with all the septic tanks that we may have in the coastal zone, that combined with increasing water levels may be contributing to this steady increase in bacteria on the Texas coast. So right now, the General Land Office is funding at least 3 research studies to better characterize what the drivers are of these bacterial increases and to then inform management actions. So my understanding is that those studies should be wrapping up here fairly shortly, so we should have a better idea of what's going on here fairly soon. So I also wanted to just give a plug for a future lunch and learn. We have one planned later this year that's going to talk about septic systems, some of the challenges that we have on the Texas coast in terms of septic systems and managing them and how they affect water quality, but also resources that are available to homeowners and communities to address septic tank issues. So just as you get your Clean Coast mailers and emails, keep an eye out for the future lunch and learn on septic systems. All right, one final shift in gear here. I want to talk now about nutrient pollution. So nutrient pollution is essentially when you have either too much nitrogen or too much phosphorus going into a water body. And what that can do is lead to deterioration of the health of the water body. So this graphic on the right is one I like to always show because what it indicates is what a healthy ecosystem looks like when you have sort of natural healthy levels of nitrogen and phosphorus. You get reasonably moderate levels of algae in the water. You get good light penetration, allows your aquatic vegetation to grow. You've got good oxygen levels for the fish and oysters. And then on the right is what we call a eutrophic system. That's one where you've got too much nitrogen and phosphorus, which triggers algal blooms in the water. It makes the water murky, so you get less light going down to the bottom. Your seagrasses die. You have issues with oxygen at times, which can hurt your fisheries. So let's take a look at where we have or might have issues with nutrient pollution. So I've got 4 data points that I want to show you, 4 indicators of nutrient pollution. The first 2 are actual indicators or actual measurements of nutrients, and then a couple others are indicators of sort of the effects of nutrient pollution. So this first graph shows total phosphorus. And the first thing you note is there's sort of these background levels. The blues indicate fairly low levels. That's good. That's what we want to see. Relatively high levels up in Galveston Bay, not super surprising given how urbanized that watershed is. Everywhere else, generally low levels. A few things to take note of. Trends over time. You see a lot of blue dots. That's places where the numbers are coming down over time. That's good. That's what we want to see. But then we've got, it looks like up in Matagorda Bay, again, few places here and there where there's some decreasing trends, but several places where there are increasing trends as well. So Matagorda Bay seems to be one of those locales where, for a variety of reasons, there's a lot of change happening there. Total Caldol nitrogen. This is another nutrient that we measure, which you see is relatively high levels in Galveston. Again, not a surprise. Baffin Bay and the Laguna Madre. It's one of those places where we were kind of wondering why this is. We don't have any major rivers coming in, but it turns out that Baffin Bay has some pretty significant nutrient issues, and the high nitrogen levels are very much indicative of that. Now, one of the good things about all this data is it's showing a lot of places where over time the nutrient levels are starting to come down. So that's good. That's what we want to see. But again, we got a few places, especially up in Matagorda, where we're seeing some increasing trends that we want to keep an eye on. So let's look at a few other indicators. Chlorophyll. this is an indicator that the state often uses for really assessing um, impacts of nutrient pollution. It's an indicator of how much algae biomass you have in the water. So very high chlorophyll levels up in Galveston Bay. It looks like we might have a hot spot here in San Antonio Bay. And then very obvious indicators of nutrient pollution down here in Baffin Bay and the Upper Laguna Madre. Now, the other thing to note is that unlike some of the actual nutrient measurements, which seem to be starting to come down in a lot of places, this indicator of nutrients, the chlorophyll, is going up in some places, especially Galveston. We see a lot of examples. Baffin Bay is still increasing over time, even parts of Matagorda Bay. So there's still, so we definitely have some indications that things are happening in those systems that we want to address. Another indicator is the dissolved oxygen. The amount of dissolved oxygen, that's going to affect the habitat quality. It's going to also affect fish, the ability of fish to thrive in these systems, for example. And a few things to note here. The oranges and reds indicate higher oxygen levels. As you move south, you see that we end up with lower oxygen levels. That's fairly natural. As you move south, you get higher salinity. Higher salinity waters naturally hold less oxygen. So this is not in itself an indicator that bad things are happening. What we're a little bit worried about is when you look at the trends over time. Again, there are some places where there are decreasing trends in dissolved oxygen. So in other words, it's getting lower over time. We have a few sites up here, like in West Bay, again, Matagorda Bay and the Lavaca Bay complex seeing some challenges. Mesquite Bay, one of the stations up in the Nueces estuary, and then one of the Baffin Bay stations. So on first glance, it's a little bit confusing. So you've got a lot of places where the nutrients are starting to come down, but a lot of the symptoms or side effects of those nutrients, like the chlorophyll and the oxygen, those are either staying put or actually giving indication that we still have nutrient issues. And so the reason behind that, I think, is because a lot of our bays are very shallow and not well flushed. And so I think what we're seeing there is sort of an indication of what we call legacy effects. So over time, as nutrients get dumped into our bays and estuaries, if they're not being flushed out of the bay, they can accumulate in the sediments. And it's almost like the gift that keeps on giving. Even though you might turn that faucet off on the nutrients going into the bay, they're still there. And it's going to take a lot of time to really start to address those legacy effects that are hanging around in the bays and estuaries. So I like to use Baffin Bay as an example of what can happen when you have nutrient pollution issues, because I think it's probably the most obvious example we have here on the Texas coast. Some of the challenges that we've had down there, we've had one of the longest continual algal blooms in history, the brown tide from 1989 to 1997. Basically, when you get these brown tide blooms, it turns the water like chocolate milk. And so then you don't get enough light going to the bottom and the seagrasses die off. And we've had several periods of brown tide blooms happening since then. This was from a paper we did showing the 89 to 97 bloom. There was one in the 2003 to 2005 timeframe. Then we had one from about 2012 to 2015 as well. So you lose your seagrass beds. We've also had issues with fairly substantial fish kills in Baffin Bay from time to time that coincided with either low oxygen events or algal blooms. So my group has been working with community members down there for about 12 years now to try and understand and address these nutrient and water quality issues. We have a citizen science water sampling program that we run that goes out monthly and collects water samples. And we've also been working with some very excellent researchers here at TAMUCC who've been doing source tracking work on either bacteria or the nutrients themselves to try and figure out what is actually contributing to those water quality issues. And in many ways, I like to use Baffin as an example, not only of what nutrient pollution does, but how you can start to address it, because we've really taken a stakeholder-led approach here, tried to get the best available data to start to identify sources and to do something about it. So like I mentioned, we formed a stakeholder group in 2018 to talk about how we can address the nutrient inputs, and then using and building upon the data that's been collected. We've developed this initiative called Bringing BaFin Back that, again, uses that data and uses it to inform watershed restoration and management to tackle those nutrient sources going into the bay itself. And eventually what we want to do is also, once we get a handle on the water quality, start to address and restore habitat that's been lost in the bay because of the water quality issue. So just a few examples of where we've gone so far. Just in the past couple of years, we've developed a watershed protection plan that provides like a menu of options for addressing water quality challenges in the bay. And I should mention that a lot of the source tracking work is pointing not towards one particular source, but to a whole smorgasbord, I guess you could say, of sources. We have issues with failing wastewater treatment plants, septic tanks, we have ag runoff, we have livestock issues. So the watershed protection plan provides that menu, that overarching, very broad menu of things that can be done to address the water quality challenges. We've been addressing illegal dumping and some of the more unsightly pollution issues in watersheds, technical assistance to municipal wastewater plants to help them get back some of their treatment ability. We're working with farmers throughout the watershed to implement conservation practices, working with homeowners, providing resources to homeowners to address septic tank challenges, especially in the more rural parts of the watershed. And also starting to really work with communities to implement nature-based infrastructure, or low impact development in parts of the watershed as well. So I've talked about salinity, so the water quality component of this, the water quantity, sorry. So then I've also talked about the fecal bacteria and the nutrient issues. So I want to just kind of pull this all together now. So with a few take-home messages, we do have localized and or regional scale examples of water quality degradation on the Texas coast that require attention. We can certainly see that whether it's in Baffin Bay with the nutrient issues or the more coast-wide bacteria issues. We definitely have some challenges there. And so again, lessons learned, I think the approach we've taken in Baffin has proven fruitful, where we've tried to get the best available data to help to understand the issue and then use that to start to take action. And again, I draw back to the bacteria issue on the Texas coast, which is kind of where the GLO is going right now. They're in that stage of trying to understand the problem and get the best available data to then start to address these issues. I think it's obviously very important what we've learned from the Baffin Bay issue is engaging with stakeholders, hearing different perspectives on these issues, which helps us to then formulate management strategies and actions, and also to gain that community support to go after funding and resources to address some of these pressures on water quality. Another take-home message, which I didn't really hammer home too much, but we have these fantastic data sets. We do have some challenges, though. And so one classic example of this that I try and stay very involved with is just data availability. We like to ensure continuity of these data sets so we can continue to assess trends. One of the challenges we ran into here is that for the TCEQ data, it turns out that there hasn't been basically any sampling in the lower Laguna Madre in about 5 years or so. And so this is one thing I want to encourage folks on this call to stay involved with or get involved with, which is that every year or two, the regional groups that lead these TCEQ sampling efforts, they hold meetings with stakeholders to decide, do we want to keep this water station or drop this water station or whatever? And so it's very important to stay involved and offer your voice to ensure that these data sets remain available so that we can continue to, I guess, take the pulse of the bays in terms of water quality. And then finally, I just want to point out that moving forward, we have to also think about the stressors that are going to continue to either function or grow in terms of water quality. And just a few examples of those. And here in the coastal bend, one of the challenges that we're seeing is real issues with failing sewage treatment infrastructure. So in this region, once you get outside the major cities, we have found that a lot of our wastewater treatment plants are probably 10, 20, 30 years beyond their lifespan. And this is a real threat to coastal water quality. And I suspect that this is an issue up and down the Texas coast outside of the big cities. A lot of these rural communities just don't have the tax base to be able to keep up with the infrastructure. And so this is just something to keep an eye on. I pulled this little snippet. This was in the Texas Tribune last week talking about state water infrastructure needs. And there's a lot of focus here in Texas right now and in the legislature on creating water, which I get it. We all need water for sure. But there's also a need to fund water treatment infrastructure. If we want to be able to maintain our coastal economies that rely on good water quality, we definitely need to be investing in water treatment infrastructure. So this example said that we need about 21 billion to fix broken wastewater systems. It's a lot of money, but we definitely need to see that in the conversation as well. Another challenge are those rising water levels that march upward in terms of the water levels. That is going to continue. So we're going to continue to see this increasing likelihood of contact with septic drain fields. So that definitely creates some challenges in terms of managing water quality, and also puts pressure on communities to either ensure that septic tanks are being maintained or consider moving off septic onto more centralized sewer systems. This also poses some threats to our sewage treatment infrastructure, especially like the wastewater plants that are in the coastal zone, especially when you get storm surge impacts. So I wanted to call attention to next month's Lunch and Learn. Since I've been just briefly talking about wastewater treatment infrastructure, Travis Prusky from the Nueces River Authority has been doing some really great work with our wastewater treatment plant operators here in the coastal bend. And he's going to be talking about, I guess you could say, the condition of wastewater plants, but and then also some of the solutions that we have and resources available to address those. So Travis will be talking on April 24th at the Lunch and Learn. And then finally, future challenges. Of course, the population growth is going to continue. We know that's going to be a challenge. And so what that really means is that, and at least in my humble opinion, we need to think carefully about how we grow. So, traditional approach of, lots of suburbs, streets, sidewalks made of concrete, a lot of impermeable sidewalks and streets, that creates some challenges for water quality. So one of the areas that Clean Coast is focusing on is starting discussions around stormwater ordinances that kind of helps us to better think about how we grow, that harmonizes our community needs in terms of growth and the economy with the environment itself. So we're going to have a Lunch and Learn in May on stormwater ordinances, and I hope everybody can join us for that. And then later this year, we're going to have a Lunch and Learn on low impact development and nature-based solutions to stormwater infrastructure. Again, kind of going back to that issue of thinking about how can we grow in a more informed and intelligent way that brings balance to the coastal community needs in terms of the economy and housing, et cetera, with the environment. So please do stay tuned for those lunch and learns. So with that being said, I've kind of reached the end. I'm happy to now take some questions, and then I'm going to leave this up there. If you have any questions about the data, the water quality, you can reach out to me. I'd also really encourage you to reach out to Ashley Bennis if you're in a community that you think could benefit from resources that Clean Coast Texas can bring. Ashley is the new Clean Coast coordinator, as you heard, and she's been doing a great job so far of bringing some of our communities into the Clean Coast Texas program as partners. But we'd love to hear if there are other potential partners out there. So with that being said, I'm happy to take any questions.
Mike, wonderful presentation. Thank you so much for sharing your information with us today. There's a lot to think about here and a lot I'm sure we're all still digesting. Just as a reminder for participants, feel free to place your comments, questions, etc. in the chat box, and we'll be addressing those shortly to break the ice and to get us rolling, Mike. I wanted to maybe flip a different page and just kind of ask you a question about you've been in this field for quite some time, and I was wondering, what are you working on now that you maybe never would have thought you would have been working on in the field of coastal research and science?
Yeah, so thanks, Jason. That's a great warm-up question. A lot of my focus over the past 10 or 12 years has been in Baffin Bay. And it's a really interesting system because, most of the examples from around the world on these nutrient issues come from systems that have large rivers flowing into them. So it's bringing all kind of nutrients and stuff, but Baffin Bay doesn't have that. So that was, from a scientific standpoint, that was really kind of surprising to see that we have these types of issues there. But I think it partially goes back to just how we've kind of grown and managed that watershed, but also just that it's not very well flushed. So that's one example from a science standpoint. Um, one of the other surprises I would say is I'd never envisioned that I would have the opportunity to take my work beyond just, studying the water and what's going on in the water, but now being able to work on working with communities to find solutions to those water issues. And Clean Coast Texas, I think, has an incredible array of resources that it brings and can bring to communities. So I'm pretty excited to be working on that as well.
Wonderful. We're excited to have you and Ashley and your team on board with us as well. Ashley, I know we have some questions coming in. Can you take us through some of those?
We do, yes. Thank you, everyone, for asking the questions. I'm kind of queuing them up here. To start off with, I thought it would be really helpful because you did touch on this a little bit, and I know it can get really confusion. Can you provide just kind of a brief overview of the difference between nutrients in the water and bacteria in the water? Kind of just give us a little foundation for those.
Yes. So nutrients, that's referring to chemicals like nitrogen and phosphorus that come from the land around the bay primarily, and it can trigger, algal blooms and other water quality issues. Bacteria, that's coming from a living source, whether it's humans, like from a wastewater plant or from a septic plant or from birds or other wildlife. Now, the interesting thing is in a lot of places where you see water quality degradation, you'll often see fairly similar sources for nutrients and bacteria. A lot of times whatever is contributing to the nutrients is also contributing to bacteria in the water. So that in some ways can make it easier to address those sources.
Okay.
It's not always the
Thank you for
case,
that.
but often.
Yeah, I feel like those can sometimes get interchanged out and they're not the same thing. So I thought that would be a good foundation. So we have a question. This might be a quick one. What is the source of data for the fecal bacteria? I think you were talking about Beach Watch, but we just kind of someone was curious about that.
Yeah, it is Beach Watch data.
Okay, so
That's what we used for that analysis.
It's monitoring and testing that they do through that program.
Yeah, Jason, would you like to elaborate on just the frequency of testing that Beach Watch does?
Sure thing. Yeah. And just wanted to mention, so that was Gabriele Benatti. He's a well-seasoned expert on Texas Beach Watch data. And so let me just ask a quick question before I dive into your point, Mike. Was what data set was that analyzing? What time period? Was it up to the most recent over how many years?
Yeah, that was the entire data set, the entire
Okay.
record.
Okay. So yeah, the Texas Beach Watch program collects somewhere between 7,000 and 9,000 samples per year during peak season. Our field contractors and staff are out on a weekly basis collecting information and posting that and having it available at texasbeachwatch.com. During the winter months, we go every other week in an effort to help save some resources and apply them where peak recreation occurs.
Perfect. Thank you. Appreciate that. Are there, do you know, Mike, if there's any sampling in the river systems such as the Brazos, San Bernard, Colorado?
So the TCEQ Surface Water Quality Monitoring Program does monitor in all of the rivers as well. So as a next phase for our coastal work, Nicole Powers, who I think might be on here, she's actually starting to analyze some of the freshwater systems especially in the coastal Bend region. So stay tuned for that.
Stay tuned for more information. Could high salinity levels be responsible for relatively low intercocci counts in South Padre, the South Padre area?
Um, well, so one of the things that would indicate is that you have less freshwater inflows going into that system, which I guess by default might indicate that you have less potential loadings into the system. But in general, my understanding, looking at a swath of water quality indicators, and for those of us who visit down there, the water is often very, very nice and clear. I think that in general, they are doing a fairly good job of managing their potential sources that go into that system and down to the coast.
Oh, you mentioned that certainly might need to have some more monitoring down there.
Yeah, that's one of the challenges is that in recent years, those TCEQ stations have been dropped. So while
Mm,
Beachwatch still monitors the bacteria, all of those other water quality indicators we are losing. So we need to get more data down there again.
okay. Thank you. And I am excited that someone threw out this next question. Have nature-based solutions been explored to control nutrient loading in the Baffin Bay watershed?
Yes, and so Ashley is actually working on that along with Athena Frasca, who's the Baffin Bay Watershed Restoration Coordinator. So recently, the Coastal Bend Bays and Estuaries program received a donation from, I got to get this right, I believe it was Apex Energy, to build rain gardens at the Sarita Elementary School and then at 4 other elementary schools in the Kingsville area. So
Mhm.
that's the start. That's phase 1. And HRI, we just got a National Fish and Wildlife Foundation grant to work with the city of Kingsville to design potentially 4 nature-based infrastructure projects at some of their community land, like a few of the places that city of Kingsville owns land down there. So we're pretty excited about that project.
Yeah, definitely. And for anyone who wants to know more details, that those projects will certainly involve engagement and outreach and education and getting the community involved to help with the decision making. So certainly reach out, use my email. I can put it in the chat again for people if you want to learn more. And then I see we have another question that popped up. Are there efforts to test the influx of PFAS, forever chemicals?
Not aware that at least not that I'm involved with. I have just heard through the grapevine that there are individual researchers who are trying to start to address that, but it's not something that my lab regularly does, and I don't know how much testing is actually going on there.
Going on there. Okay. That's good to know. Thank you, Mike. Okay, if there's any other questions, please throw them in the chat. I do have a question kind of thinking about when you're talking about septic systems, sea level coming in, that kind of influx, and maybe there's some leaching. Do you know if there's some opportunities or activities happening in this region to like regionalize the wastewater treatment plants to kind of help with some of those septic issues that we're seeing?
Yeah, so in the Baffin Bay watershed, the Nueces River Authority has a design out for a regional wastewater treatment plant that would pull offline at least 4 communities down there, and also some of the colonias that are either on septic or have very minimal waste treatment. So the challenge is the funding. There are very few options right now in Texas to actually support communities who want to improve their sewage treatment plants. It's again that's one of those things where, yes, water quantity is important. We definitely need that, but we do need funding because in my humble opinion, I feel like the sewage treatment infrastructure on the Texas coast is a ticking time bomb. So I feel like we need to have more resources to address this.
Thank you. Some positivity. And then you had mentioned people can get involved with, I believe it was TCEQ, correct me if I'm wrong, to kind of have some input on where to monitor or monitoring stations. Am I getting that correctly? I just wanted to kind of bring that back around in case people were interested of how they can be more involved in making some of these decisions.
Yes, so this may be something that we can include perhaps in a future Clean Coast newsletter, just dates and locations where they talk about the TCQ SWICM monitoring, where communities can provide input. I don't know those off the top of my head because it's very region specific, but
Okay.
that might be something that we are able to do in the future.
Can I share more about that? Okay.
Yeah.
And then, yeah, I see the question about recording is yes, we are going to be posting this up. We have a lot of our previous lunch and learns on YouTube. If you just kind of search in YouTube for Clean Coast, Texas, they should pop up the other lunch and learns. So we will be sending out a link to that recording afterwards so that all the attendees here can have access to that and share that with other people who are interested. I'm not seeing any other questions pop through. I know we're getting kind of close. I don't know if there's any other last words or any last kind of sentiments we want to share here, but yeah, I'm seeing no more questions.
Well, Mike, we really do appreciate your time right here, lending your expertise and sharing this information with both a wide view and a deep dive on a couple of topics. We look forward to the other lunch and learns that are coming soon. So thank you for highlighting those. And this, in essence, is a Clean Coast, Texas advertisement. We are also looking for partners, local community champions, and decision makers to join us and to help tackle some of these important issues on enhancing the management of stormwater. On behalf of the Clean Coast, Texas Collaborative, I'd like to thank Ashley, Sarah for co-hosting today. And again, Mike, for providing your presentation today, as well as our collaborating partners, Texas Community Watershed Partners, Meta Center for Water and the Environment, and Texas Sea Grant. And then, of course, our funding mechanisms, Coastal Management Program through NOAA. So thank you for supporting this program. We look forward to working with you all, and let's keep our Gulf Coast thriving. Thank you.
Thank you.
Thank you, everyone.